Recording is back on. So let's actually look at the program that we're running. We're running L3, so it should be this one. I don't remember, did L3 code gen works? I think it did, right?
It did, yes.
Okay. Okay, so the first thing we do is call A, which is correct. Then we allocate uh, we
We
allocate
allocate a
one permanent
permanent,
variable, permanent register,
yes,
which is this. Okay. Then we put variable, which I think is just I don't remember. Put variable is the one going left to right, or I don't know. I keep forgetting.
Put variable is actually going to initialize a new variable on both arguments, I guess, both registers.
Okay, let's. I guess that should happen. Then we call B1, which is true. There is no permanent registers in here, so it's allocate 0. We do a get variable, and then a put value, so this is a no op. Then we called E, great. That goes to here. It goes to here. That is a try me else, which makes sense. And we're gonna jump to 12, assuming that this fails. Uh,
Yes.
there are no permanent registers in here, so we just call allocate 0 again. No op again. Call F here. That does a get structure. That does a get structure on Y, and then it blows up.
And then it blows up.
So as far as my memory goes from last time, we want actually to be able to go to the evaluator and go to the get structure, like so. And we need to put some prints in here, I think. Am I right?
Yeah, you are right. I need to figure out what's going on.
Yeah, where are we going to print this stuff? So my understanding is that the print tells us what is y supposed to be. Where are we? We're doing a set somewhere, right? We're doing a set somewhere. I'm gonna guess that it's in here.
Yeah, it's the two heap puts, they are both finger tree sets. Basically, they're saying, okay, I have a finger tree. I'm going to set the value in a particular position because it represents memory, right?
Yeah. So the question
And
now is, how are we getting out of bounds? That's kind of the question.
that is a very good question, actually.
Do you want to look at the code gen?
I think, actually, it might be better if we print the age register as well.
And why do we need this, by the
Yeah.
way? Oh, it's because this is creating a record. This is updating a record. Okay, I see. Okay, so you want to do print in line string of int, and you want to see the H register. Is that right?
Yes.
Okay, so let's do it. 101.
101.
Wait, this is outside allocated memory. I'm pretty
Well,
sure.
yes, because it points to the next free cell, basically,
Yeah, but that
in the heap.
means, does that mean that this program is overloading, like, well, not overloading, what is the terminology for that? It is too big?
Overflowing.
Overflowing, yeah? Is that what that
It,
means?
it shouldn't be. Hello, Mageta.
Hello.
Hello, Mageta. How are you
Are
doing?
you tired, Mageta?
Man, I woke up at 6 a.m. today. I'm very tired.
Oh, okay. I'm also. Well, we are always tired in here.
Are you
I am
recording, by
recording,
the
by the
way?
way.
Oh, okay. So I'll talk about what I did later.
Sure. Okay. So that's the thing, Marinho. So we have 101 in there, 101, and we're getting a
Uh,
segmentation fault.
hmm.
I wonder why and how.
Go back to the terminal, please. I wanna see something.
Sure.
So we do a put variable, and that should allocate, which is correct. That's why the age register is 101 because we already allocated one cell of memory. Then get variable, put value, none of that should allocate
Wait, wait,
anything.
wait, wait. Shouldn't we have two put variables then? Because we are doing this. We are doing two puts.
That's when you do a get structure, actually. Get structure is slightly different.
Ah, I see.
Then we do the get structure, which should allocate, well, in this case, it should allocate only two cells of memory.
Mhm.
But somehow it's failing with an index out of bounds.
And there's another thing that I also remember. The backtracking was working, right? I think we ended up like having a not in, infinite loop, but the backtracking was working, and then we fixed something, and now it's not working again.
Yeah.
Okay, that's cool. Uh, okay, so let's go through the instructions that should, um, I don't know, allocate the memory properly.
Well, the only instructions that allocate memory that are in this execution are the put variable and the get structure.
Okay. The put, let's go the get structure. It checks if you have a reference in there. Well, actually this, if it has a reference in there, we know there is because this is printing. Then we create a structure, create a functor, and then we do two puts. Um, man, let me also, I don't remember. Do you remember what the size of the memory? I don't.
The size of the
Yeah, heap
memory.
size should be 101, starting at 100, right? Because from 0 to 99 is the code, and then
Yes.
from 100 to 199 it should be the heap.
Yes.
So how are we getting something out of bounds? That's a little confusing to me. Mm, that doesn't make sense.
Uh, you know what we can do, actually? We can put
What?
a print after the let.
You mean here?
Yes.
But that will not print, right? Because it's failing before that.
Are
Let's
you
try.
sure, Lemos?
I am. I wouldn't put money on it, but I'm kind of sure. Should Lemus be sure? Yeah.
All right, you are sure. Well, you should be.
There's also bind, by the way, which I don't remember. Is this doing any sort of?
Bind does a write as well, yes.
Ah, this is the new bind. Oh yeah, yeah, yeah. We need to take a look at that actually because we cheated. Well, not really, but we kind of cheated, and we looked into the appendix of the book to see the final versions of the implementations, right? And we
Right.
don't even know if those versions are considering optimizations or some shit. So that's always great. So I think it is. Yeah, I think our brains were melting when we rewrote bind. I think that was the thing. And I also think we should revisit this monster here.
We
Uh,
definitely should, yes.
yeah, this is definitely optimization. Unwind, trail. Yeah, let's actually review those implementations, man, because I feel that we may we may have done some wrong stuff. Okay, so first things first. First things first. Do we know for a fact that those writes and reads are happening in the heap?
Uh, do we know for a fact? Not necessarily, actually.
Not necessarily. Okay, but then what do we do?
Don't we have store puts as well?
No, we do, but I'm kind of like this exists and this exists as well, and puts also exist. I don't think this will make any difference. Yeah, because the only difference that this does, the heap ones, they're just checking boundaries, right? If these
Yes.
succeeded before, that means that these numbers are within the heap range anyway. That's what that means.
Hmm.
Uh, so let's actually go back because that doesn't matter. And I think the reason that we did heap it was because the original version of bind was already doing heap. That's why.
Probably, yeah.
Okay, so let's check the if. So we do a get on the I1, we get a tag, then we check.
Actually, put a print at the beginning of bind, and let's see if we actually are even entering bind.
Oh, we want to see if the puts before above the bind are the problem. I see. So bind. Bind.
Huh, we are actually going into the bind.
Yeah. Uh, then we check if T1 is a reference, and we do that. That's nice. And and we check that either T2 is not a reference, T2 is not a reference, or I2 is smaller than I1, right?
Right.
Then, if that's true, we return a computer in which we update the store, passing the value in I2. We index the store using I2, and we write that into the position of I1. And my understanding Hmm. Okay, I think I found it. I think I found the problem. So here's the problem.
Okay.
Do you agree that if we enter this if, we know for a fact that whatever is in I2 is not a reference?
Do I agree that whatever is in I2 is not a reference?
If we enter this if.
I disagree actually.
Oh, actually you're right. It may be that this is true and this is true, but this is a reference. That
Yeah.
is okay. The problem is that we are kind of assuming it is a reference. You see the problem?
No, we're building a reference that points to the address of the original thing.
That's uh, that's not okay. I'm gonna change my question. Do you agree that whatever is in here, it's exactly what we are writing in A1, right?
Uh,
Do you agree on that? I think that's it. This should just be this, and the same here.
okay.
That's not the problem. But that was wrong. We should not have assumed they were references in there. Well, in the particular case of the else branch, we could assume that because if we didn't, actually, yes, we could because this is an AND, and if this is false, Actually, it was the opposite. We knew for a fact that this is not a reference. But this is fixed now anyway. But it is still not correct. So one of those puts are incorrect. They are maybe both. Maybe. Let's actually check the implementation of trail as well. Trail. So what does trail do? It receives a computer, and in this particular case, where is bind? The trail needs to happen after. Now that's a question. We are assuming that this is all mutable, right? That's why the order for us mattered, right?
And that's why we're passing the computer after we make the change inside of bind to trail,
Yeah,
yes?
I'm starting to. No, that would be too broken, right? If that was not an assumption. Like this must be an assumption, right? That this needs to happen before that.
Yeah, we need to first update the store and then we call trail.
Yeah, that makes sense. Okay, so trail. We check if A, which is an argument, if that is less than HB register, or if H register is smaller than A and A is smaller than B register. If that's the case, we return your computer, passing, we write into A.
I wonder if the trail put is breaking, actually.
That's interesting. So how the heck I'm gonna test for that?
Put a print before and after that.
That's annoying because this is in a pipe.
No, no,
You
no.
know what to do, Lemus.
Inside of trail, Lemos.
Inside of here? Sure.
Yeah, yeah. Just put a print that we're inside of trail. Then,
Then
then do a let inside of the then branch.
let C equals
Yeah,
in
pull out the trail put from the computer. That works as well.
C trail true. Trail, but no trail true. So this is broken.
Yes, we found it.
We found it, boys.
By printing, the best debugger.
Lispers are proud. What's the problem then? I'm confused. So let's actually check the implementation of this function because I think this is the first time we ever use this. Isn't trail the one that grows backwards? Or am I going insane?
Yes, it grows backwards. It grows
Ah,
backwards.
okay. So wait, but does this matter for this specifically? Does that matter?
It does because the trail start is like later. Let's go. Let's go to the. Let's go to the memory layout real quick.
No, the trail start is the PDL start plus the trail and PDL size combined. I think this is what you want to know, right? The layout is just a bunch of hundreds.
Okay, so the trail start is actually at the right position, but we're using the same limited put, which assumes that the memory we wanna check is after the start position, not before it.
Yeah. Can't we just swap those two things, or am I going crazy?
Uh, Actually, let's try something else first. Can you put a negation around the trail PDL size?
A negation? What do you mean?
Yeah, arithmetic negation, like make it negative.
Does that happen like this in OCaml?
I think it's a tilde, or I might
Tilde.
be wrong. I
Okay.
might be wrong. I
Well,
might be thinking of SML.
sure. Tried reaching illegal memory region, ceiling or floor reached. I think that's yeah, that's definitely an error on this guy. Yeah, and yeah, the or minus didn't work because of this, I think.
Hmm.
Because the size is negative, and the size being negative, yeah, that's gonna fucked up. Okay, we have another potential solution, which is to re-implement Well, for now, just copy paste because we can just refactor this later. We can make another limited put specifically to trail.
We probably should, and here's the problem actually. The
Go for it.
the problem is that the trail size is dynamic, and so is the PDL size actually.
Yeah, you said that. Here it is.
Yeah, yeah.
Yeah, we knew that. We knew that. So that apparently came, the time has come.
Actually, before we do that, there's something else I want to try out.
Mm.
Make the trail put use trail start plus one.
Like this, and remove the
Yeah.
minus in here.
Keep the minus. Keep the minus.
Keep the minus. Wait, this is gonna break. No.
Nope. Ah, okay. It's not enough by one then. It's something else, maybe.
Wait. Let's try to identify the problem. So we are having segmentation fault. That means that whatever this is and whatever this is, the floor
Oh,
and
you
the
know
size
what
are
it
are wrong.
you know what it you know what it could be actually.
Go for
Go
it.
back into the limited put. I think I might know what the issue is.
Go for it.
Uh yeah, we're doing a put element index memory. Is that a problem?
It's because on this module we
It shouldn't be.
yeah we interpret it as a gigantic array that we pre-allocated, and then we just index it.
Go to the initial initialization function. Well, the initial computer, I guess I should say.
So you're talking about this.
tr register
No,
equals trail
yeah,
start. Make that a trail start minus one actually.
yeah. You really want to discover that there's a uh, uh,
Not quite.
no, no.
Um,
Wait, if this is backward, shouldn't this be the size then? Or am I going
what do you
crazy?
mean? It should be the size of a cell, which is one by definition.
No, 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 no. I mean, um, this should start instead of from zero from like, uh,
It should be the trail end actually.
yeah, exactly. That's what I'm trying to say. Thank you. Okay, so we should have a trail end, which is interesting.
Actually, the trail start is already the trail end because the PDL start plus the trail PDL size and it grows backwards.
Okay, so that is the problem. The fact that this was okay, so that's improvement. We have this, but this is the floor, so this is wrong, right?
This should be a ceiling, yes.
Yeah, but that's not going to work because limited put expects a floor.
It expects a floor, limited get as well.
Yeah, isn't the floor this? That's my question.
Trail PDL size, no, because that's not an index.
Wait, but this is.
Yes, the PDL, not quite, because the floor is dynamic, actually. That's part of the problem.
Ah, that's okay. I see. I see. The floor is dynamic. Holy fuck. Ah, okay. What's the best way to solve this? I don't think we can cheat. I think we need to implement it properly now.
Well, we need to get the... Wait.
It's complaining about I changed the name of this stuff. The stuff. Let me. Yeah, this. There we go. Let's try to implement this properly, man. Because I
Hmm.
think we're trying too hard to cheat.
You know what it could do?
Tell me
Looking at the
about it.
implementation of the trail function in the book, it
It's
seems
easy.
to assume that the trail actually grows in the same direction as everything else, right? Because it's incrementing instead of decrementing.
That's true.
Why don't we just
But isn't that what we're just trying to do? Like that was the state before, right?
no. Before we were using the way that is done in the paper, where the trail grows backwards. But apparently the book changes that to make the trail grow forward.
No, no, I agree. But my question is, isn't that what we were doing before we started changing this file? Or am I wrong?
No, actually, because well, is it?
Yeah,
Go.
yeah, it was trail start, and then it's the floor, and this is this, right?
But we have a trail PDL size, which means actually to make it work properly, we need to
Separate the trail from the PDO.
yes, the sizes specifically, because right now they are together. Well, they are the same, I should say.
Mm-hmm. Mm-hmm. Okay, so do you want to introduce like PDL size and trail size? Is that
Yeah,
okay?
PDL size and trail size, and then we need to, if we're not doing it already, we need to put the trail size number of cells in the memory initially.
Are we not doing that? Are you sure?
We may or may not be.
We may or may not. Layout. So this is
Trail
trail
size.
size, but this is not happy. And I don't know why. I'm gonna assume it's just LSP being broken. Oh, I wrote it wrong. I wrote it wrong.
Did you add it to the signature?
Yes, I did, but I wrote it with a typo in there. Okay, and then we will have a trail start, which is gonna be
PDL start plus PDL size.
PDL, yeah, like this. And then we're gonna have a trail end, which is just trail start
Uh,
plus layout trail size. And then the
I don't
puts,
think that's necessary actually.
no, it's not necessary, but just to be symmetric with everyone else. So this, oops, this is start, and then this is just trail end.
Trail size actually.
Oh, that's actually true. Okay, so never mind. This being symmetric. So it goes here. Change this to this. Cool. We don't need this. So fuck that. They are not united anymore. So fuck that as well. I should change this back
Dilemmas
to
today.
start. Sorry.
Evil lemons today.
uh, okay, so that means that in here we need to actually provide another memory section called trail, which is interesting. Let's see what the compiler tells me. Yeah. Okay, we went further this time, which is great, but I don't particularly liked it because I think we should have backtracked.
I think we did actually.
Are you sure? I am not so sure.
Yeah, get rid of the extra print. Let's just see the instructions instead of the extra stuff.
I think there's another print in here. And there we go. So all of that stuff. And
All
now
right, so we call
let's
A,
L3. So let's go.
call A, call
Call
B,
A, call B, great.
call E.
Call E, try me else, because this has choice points. Then call
Call
F.
F.
F should say no, should say okay, X needs to be Y, friends. It proceeds, deallocate twice. Then we call C, which is
Then we
up
call
here.
C.
Get structure on X, because this. And this
But it
should fail,
fails.
because
It
X is not Y.
so it fails and it jumps to the
Trust
trust
me.
me.
I still can't get over these names. Okay. Then we get the get variable on the. Well, I'm assuming you are now doing this thing.
We call G.
Yeah. Then call G on it, which is X. Deallocate, deallocate, and then we agree with C that capital X should be actually non-capital X, and that just works. Bam.
Amazing.
Okay, so it was easy to solve actually. We just had the freaking trail problem. Backtracking works.
It actually works.
Backtracking works. But we didn't test having three though, because you remember that there is a retry.
Yes, I do. And
Z. This should be enough, isn't it?
it should be, yes.
So let's go. Boom. That was fast. And
Yeah, it
retry.
does. Yeah, it does go through the retry me else. It calls Z, goes up to the call to C and fails again. Then trust me, and then it works.
Okay, so we are at the position that we have. Is this? I'm not into logic programming. Is this Turing complete already? Like, can we do everything?
Ah,
Assuming we implement
You,
literals, of course.
you have recursion.
But isn't it recursion done via backtracking in these languages, or am I
we do have
wrong?
recursion actually because you can call. Hmm. Actually,
Let's make a
do we have
factorial
recursion?
example. How do you write factorial in Prolog?
No, we do have recursion actually because when we do a call, we bind to the predicate symbolically, and we emit a table of bindings for each predicate name together with the program. So we should be able to do recursive code, yes.
That's great, but let's do you guys know how to write factorial like easily?
I do, but we don't have numbers.
Yeah.
You can make functions. You can make relations, but you need to make a totally ordered relation.
Wait, before we do all of that, shouldn't we print the like because again, this is the pinnacle of
Sounds like
the machine getting hot and nobody knows the output.
no one knows what's going on there, right?
So let's actually do the strategy
Oh,
of
but
like
you know what it reminded me of?
what?
Um, Wadler, right? When he gave that talk to us, I don't know if you remember. Uh, he said, "Oh, back in the '90s, people were very excited building this this computer, like this machine that was like purely functional. Uh, but then people finally developed the whole architecture, and it was like 10 times slower than a normal operating system, and then everyone gave up. That feels like that. Like we made a beautiful language, and then it's slow and it doesn't print, and then people just give up.
It is not slow, man. Like it is instantaneous. Come on.
Oh well, you're running garbage programs, man. The heck.
No, of course, but what do you want? It's faster than I would expect, especially because we are not going to like assembly. We're just doing our own code generation. Just like fuck it.
Uh, Let me see if I can write a factorial using lists as numbers real quick.
But do
Comes
we have? We don't
first.
have literals. What
Yeah,
do you
I
mean?
think it's easier to write integers, right, on the language. I
But we
would do that,
do.
folks.
No, no.
That
But
might be useful, you know?
oh no, we don't have no, strings. We actually have uh, uh, like atoms that can be like with spaces and whatever. There is a PR to do that. I forgot. Anyway, let's implement. Let's actually do a commit, and then let's actually. Sure. Ooh, actually that's a good call. Let's go to the git ignore. Let's put dranv add dranv support, and then I should have committed that with the git ignore, but who cares? And then here we're gonna say finished, finish
Ah,
backtracking. I was expecting to be way worse. Cool. That's print now. So what do we need to do? We need to remember the queries, right? I think that's what Marinho had the idea.
1 second. Let me just try to do something here.
Oh, I saw your message, Nathan. I'll reply in a bit. I'm just finish a thing here. Running around like the speed of sound. Man, I think I am psyoping my boss because
Be
every
careful.
time that
Yeah,
I
I'm recording this shit.
yeah, that's fine. Every time I talk to him, I mention Sonic. so, so every time it's like it's a different meme, right? Of like Sonic being a furry or things like that, uh, and then he started like reacting with emojis of like Sonic to every interaction that I have with him. So yeah,
He is into it. He is into it.
he's
That's so
into
cool.
Sonic, I
That's so
suppose.
cool.
Actually, let's not do factorial because that requires me to implement multiplication. I'm just going to do triangular numbers instead.
That's fine. But how are
That's
you going to do
lazy
that without
Marinho.
numbers, man? Can I ask? May I ask that?
Do you know how numbers are implemented in independently typed languages?
No.
They are linked lists.
Oh, piano numbers.
Yes.
Great stuff. Okay.
I mean, obviously they are optimized like to actually be represented as machine integers, but at the semantic level, yes, they are piano numbers.
Cool.
Sounds like absolutely trash, to be fair.
Wait, wait. But then, how are we gonna do that? I'm not understanding. We don't have any literals. How is Marinho implementing anything?
Um,
Am I
I think the
nuts?
relation, like recursive relations, they can be lists, right?
But there are
Yes.
no literals.
There are, well, we have functors. That's sufficient.
Yeah, if you have a base functor, like a functor with a base ending, that's the base case of the list, and then you just need to treat the rest as cons, right?
I'm very curious to know what you guys are talking about.
I still think it's easier to just add a num integer as value. I don't know why you guys are doing this, but okay. To me, it still sounds insane, but okay. Go ahead. I'm
Third
used
month
to
of
it
the
by now.
project, right? I don't. I lost count, Commander. How long it's been? But theoretically speaking, it is to incomplete now, which is great. Let me actually look at the optimizations that we're not gonna do right now, and without printing, and without printing. But it can't do anything. That's the Chad move. Let's read. Let's read optimization. So my understanding is that we're not gonna do any of them aside from the tail call. uh, chapter 5. Yeah, this is where the optimizations reside.
Designed.
Mm-mm-mm. Where is it? The start 5.9. Damn. 510. Damn, there's more optimizations than language in here. Okay, that's cool. Okay, so let's start. Heap representation. Nah, memory's cheap. Next. Variable. Okay, literals. Okay, so the one optimization, it's classified as optimization, having literals. That's cool.
Well, it
Optimization.
is actually an optimization.
That's.
Totally not necessary.
Uh,
Oh, they have special names. They are called anonymous variables. No, that actually makes sense, but nobody would ever thought that. They're cool.
okay, so I have equal, I have
Wait,
plus.
wait. I have a question. Uh, our program does not do unify, right? This program does not do unify, does it?
Well, it kind of does.
But the unification is just comparison. Am I wrong?
What do you mean? Oh,
I
right,
want.
we don't actually do unification on structure. That is correct.
Yeah, so we don't know if unify the cursed unify works. Where is it?
Uh,
Yeah, this thing. We don't know if any of these works. That's awesome.
let's see. Triangle of n needs to be triangle of n. The accumulator is new, and the output.
Man, I'm very scared about the program Marinho's writing, man.
I'm expecting something cursed, but at least I will laugh.
Okay, so there is an extra. Okay, so they treat constants especially. Damn, constants have a special cell in memory. Okay. Wait, so Magetta is wrong. It's harder to put numbers.
Oh, I was guessing. I don't know how to put numbers. Mario is the
Ah,
Damn,
revolutionary mind here.
you need to put more. Man, that's a lot. That's actually a lot. Yeah. In, okay, maybe I'm stupid, but I was kind of thinking that we would add in memory a literal cell, not one per literal. That's kind of weird.
well, you do need to have one per literal because each literal may be different from all the others.
Yeah, but I thought we could just like do some special trickery to make it easier. Because the way that we are doing here, for each specific literal, we're gonna have to add a bunch of operations, man. Bunch of operations. Yeah. Unify void. Mm-hmm. What does it do then? I'm looking at examples. It does. Yeah, that's a program. Yeah. Well, that's actually a query of a program. I don't know how to explain. I don't know the nomenclature. Marinho and Magetta they know.
1 plus
Uh,
Of
2
what?
plus 3 plus 4 should be
like,
10, and this
do,
should
it,
be
is
relatively
it
easy
fair to
to.
say that a query is a query of a program?
Uh, the query is a query of a program.
Yeah.
I, I
How do you make the relationship between predicates and facts and queries? In speaking terms.
well, a predicate Okay, so let's go on logic first, right? Because I think it's easier to map. Uh, so a predicate in logic, it is like a function, something like that. A function is a predicate, rather. So you evaluate something
Mm-hmm.
uh, with its truthful uh, value, right? So a predicate is like a table in SQL, let's say. So you can put variables, and then you have the tuples, which are the for the proposition that lead to a truthful statement. Uh, what's the other?
There we go.
Or
There it is.
oh no,
Okay, I'm sorry if I get to, but I need to read this. So let's go.
plus.
Okay, so let's actually create an example here. So this is gonna be triangular Karuta. So boom, boom. Okay, so here's our program. Here's our program. Ah, okay, so that's how you're making numbers. I see. Okay, so let's read this. Let's see if I understand. Okay, so am I correct in saying that, man, I remember this from a master's class, like that I did in university. I remember plus being like this. So if you have nothing plus something else, the answer is, uh, yeah, I don't remember. Why do we need the equals here, Marinho?
Because we don't have syntax for that.
We don't have, oh, no, no, no. Let me refine my question. What does the equal have anything to do with the plus? That's my question.
Well, uh, I'm basically saying, okay, this is how you unify two variables, essentially. That could have been done probably better if I just did out and out, but actually, let's do that. That's better.
Wait, but no, 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 let's not, don't do that. Let me just ask a question. So you're saying that 0 plus x equals alt. You're saying that x is equal to alt because there's a 0 here. That's what you're saying, right?
Uh, yeah.
And this is the same, but like reversed.
Just one thing. Let me use this example because I think it's a good one to clarify the terminology, right?
Hmm.
So what is a term? It's either the constants, so the new, uh, equal as well, or the variables like x out, right? So those are terms. Why? Because those are basic elements that hold the truthful values. They themselves are true. They cannot be false, right?
Yeah.
So it's like saying turtle. Well, is that true or false? I don't know, man. It's a turtle.
Yeah.
Uh, so a functor. Why is it called a functor? Because it's basically the what's holding the structure for a function symbol. So you're basically looking at something that is true. So I don't know, father, and then João. Then who is the father of João? Well, don't know, but João is a father, right? That's the statement.
Yeah.
So the functor is just holding that statement. A predicate is holding a relationship between terms. So
Yeah.
it's like that's what I meant with the SQL table, right? So it's like elements inside of it, they are tuples, and then you're
Hmm.
holding. So in that case, for example, the predicate definition that Marinho did there on plus means that it is equal, that equal must hold. You see? So that is true if
Yeah.
that predicate holds.
Yeah,
So
yeah, but
that part.
wait, pause. I think it's important to have that terminology conversation, but I just want to understand. The result of this plus will be in out. Is that correct to say?
Yes,
That's
that's the
the
term
intended
that's
usage,
unifying.
but you can technically run it backwards,
Yeah,
theoretically.
you can put the output and see what gives
Yeah, yeah,
inputs.
no, Magetta did that in his presentation, right? He did exactly that. But I'm still no, it's very weird for me, man. And I know it's a skill issue. That's what sucks the most. To understand how to think this way, like these are predicates and true
And
statements. They are
the thing
not
that I got
functions.
red pilled with this is think about this.
Fuck.
In a Turing machine, you have the
Okay.
transition of states in the tape, right? That's very mechanical. It's very easy to see.
Mhm.
The transition of states here is by relations. So it's by holding the relations between the terms as they get unified.
Yeah, but I cannot not look at this and try to make it a function in my head. That's the problem.
By the way, Lemos, you should take the new version of the code because it's shorter.
Okay.
That's even more autistic, man. Congratulations.
Okay, let me see if I got it. So,
You didn't change the code.
what do you mean?
I posted a new version on the chat that's shorter, but you didn't replace. There we go.
Okay, there we go. Okay, so let me ask some. Okay, so I understood what you did. I understood. So if you have nothing plus something, it's equal to the something. Oh, so this is basically the base case. Like this is the factual information, right? This. This is always
Yes,
true for everything. If you have something else that matches this pattern, you actually rewrite this as this. Is that correct? Hello? Yes, Commander. This is prologue like, yes. Uh, Mani,
yes, I'm back.
Uh, is it true to say that when you pattern match this, you're actually going to rewrite it as this?
Yes, it is.
I have another question. How are we summing? How are we changing the value of out? That's my question. That's why I
Well,
always get confused in
well,
fucking logic programming.
it it tries to unify to make the predicate true, right?
It tries to unify it to make the predicate true.
Yeah, like the relation plus, it will search and say, what can I fill in the out to make this statement true? So like
Got
it's like
it.
this, like one
Got
plus
it.
two. So it's like one plus x equals three. What can you fill in the x to make it be true, which is equals to three, right?
Mm-hmm.
And then it will show like two. I don't know.
Got it. Got it. Okay, that was helpful. Thank you, Magita. So essentially, this is the recursion, and these are the base cases in this case.
yes.
Yes,
Yeah. Okay.
those are simple facts,
Because
right?
if
So you're
this
stating
is
those
new,
things are
we're gonna
true.
go to here. If yeah, if you reverse the order of the numbers, then you're gonna go to here. But otherwise, you're gonna keep going to this every time because previous will still be a number that is not zero. Well, not new. So you're gonna keep pattern matching the successor, and then you're
New
gonna
means 0, by the way.
yeah. Okay, so this is just the same but triangle number um, um, equality thingy. And then in here, we are making the query. So this is the question that we're trying to answer. So we want to know, this is 4, right? This.
That is 4, yes. Well, to be more precise, it's the successor of the successor of
Ah.
the successor of the successor of 0.
Okay, Maria, we're not that dumb, man. That's
It can automatically solve simple linear equations. My understanding is that this can do everything a Turing machine can. Not our
I mean,
version, probably, but
I
in the
just
future.
wonder what would be the representation of a floating number, but that's for another.
Marinho doesn't want to know that. I have a question. So what is should be the answer of this? So triangular. I thought triangular numbers you pass more numbers to. You just pass one.
Yeah, you say which triangular number do you want? And it's basically okay, it's the sum of the number plus its predecessors.
Ah,
It's like factorial but with addition.
yeah. But isn't this the symbol for that? That's kind of funny. Isn't it like for this that what Marinho just said?
I'm asking for the fourth triangular number, which is 1 plus 2 plus 3 plus 4.
Yeah.
Yeah,
So.
well, the fifth actually, if you because we're 0 based, which is
Uh,
represented by the number 4 in
okay.
this case.
Okay. But anyway, so that's kind of funny anyway that the symbol is the same. Okay. So what should I expect? Well, there's no printing, so this shouldn't actually don't do nothing. But let's see if we halt. Let's actually see if we halt. Actually, that's a good question. Should our language be capable of doing stuff like this?
Doing
It
what?
should.
It
It
should,
should.
right? There's nothing in here that. Wait. There is a memory issue here. Maybe this is gonna do segmentation fault actually, because this program may be too long.
I don't think it is.
Boom. Unreachable. Get structure. Interesting.
Oh, unreachable. That looks like something you
No, yeah, this
guys
is a problem in
people
the
may.
compiler. This is a problem in the compiler.
It's
Should
actually
your
a
language
problem
be
being
capable of producing at least some sort of output? No, yeah, we are working on it. We are working on it. Go, Marin.
Yeah, no, yeah, but this is actually a bug in the evaluator.
Wait, shouldn't we check the code first, or do you have faith?
We could,
That's
yes.
Okay, so let's
if
check
you
the
get it
code.
right, that's absolutely sane.
Okay, so let's go. So the first thing that you do actually is put structure, believe it or not, on the successor. I don't remember. I think we're changing the order of shit, right, Marin? The order of the
Are we?
code is no longer the order of the generated code, right?
Not necessarily, no.
Yeah, because these successors are coming from here, right? Or am I wrong?
I think so, yes.
Okay, so we start from the Krieg. Healthy dose for the night.
Uh, Speaking of healthy dose, I should probably get something to eat. I'll be right back.
Okay, we do successor 4 times, and that to me seems correct. I don't know if the put structure is the correct instruction, but that seems correct to me. And then there's the new, which is okay. Then we do a set variable. Good, see ya, Commander. Then we do try me else. Ah, of course, because this has backtracking. Because there's 3 definitions of triangle. Actually, there's 2 definitions that matter for backtracking because this is, I think, classified as a separate one. So we do, where is it? Oh yeah, triangle. We halt. This halt seems incorrect, but okay. Uh, then we do a try me else, which makes sense. We're probably gonna try this one. Yeah, this one first because it appeared first. So we do new, get variable and get value. This is a no op. No, this is not a no op actually because this is 4 and this is 1, but this is 4 and this is 2. Mhm. Mhm. Then we proceed because, well, this is a fact. There's nothing to do here. Then we do the trust me, which means going here. We allocate 3 things. Does that make sense? 1, 2. Huh. Why is allocating 3? Oh, because of this thing. Okay. So there are 3 permanent variables in here, so we allocate 3. That seems correct to me. Um, then we do a bunch of get variable to put the arguments into the registers. And we finally call success. Then my question is, are we calling this success or this one? I have no clue. And here it is the unify, which again can be completely broken because nobody trusts that implementation, actually. Um,
Maybe you're back. I'll have lunch, dinner actually.
yeah, dinner was weird. Well, lunch was weird. Go have dinner. Where is Marinho, man? Well, I'm gonna just assume the D successor is gonna be. Uh, oh, but this is just a functor. I don't think that really matters. And then we call the plus. We actually call plus. So we're calling this plus probably. After that,
And I'm back.
okay, I think we are kind of there, but I don't know the instructions on top of my head like you, Marin. So my
All
first
right.
question to you is these five things. Those are these things, right?
Yes.
Okay. So then we call. Well, I don't know if the set variable makes sense. I don't remember the use case for set variable anymore.
Well, in this case, it's being used to initialize a variable in a register that's fresh
Is that
because
the
this is being
out?
introduced. Yeah, it's the out variable.
Okay. Qual triangle. This is back. This will have backtracking because and it's gonna try this one first because it's the first one appearing. Which, by the way, we probably should change that. We should put facts at the bottom of the chain, not on the top. Well, not relative to the how the file does things. Then we do
What
the
do you
try me
mean?
else. I think you should prioritize when doing the attempts on predicates with bodies instead of just facts.
But I can't.
What do you mean?
The first thing we need to do is check if we're in the base case.
Wait, does that mean that if I swap the order of this and these, it will break?
It will actually. Well,
That sucks.
in this case, it might not because well, the pattern matching is exhaustive on the first argument.
Yeah, that's what I thought. I just
Yeah,
think,
no, in this case it should work actually.
yeah.
It should work to swap them. But
But you made a good
the
argument, which is that we should test base case first. And it's just that I think it's kind of wasteful because we know that we should start from this one. And but you're right. These can go over way overboard.
no, no, the first thing we need to do is check, are we in the base case or not? And that's what we're doing with those two clauses together.
Yeah, we're doing try me else. Then this new is this one, right? Then I have a question.
Yes.
Do we have two? We have one get variable and another get value. Are we moving out to one and out to two?
Are we moving out to 1 and out to 2?
Is that what we are doing?
Uh, we're doing, we're calling triangle and then halting. And then this is the body of, let's see, new and then get variable and then get value.
Yeah, the get variable is because we're introducing out for the first time, and I
That's
think
not,
get value is this.
I'm not sure if that's actually the triangle. Is it?
Yeah,
It is. It is because there's a
definitely
trust
is.
fee.
This and these I think are the clues.
No, 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 no. The other one from 0 to 7, which is the halt, that's the compilation of the query. 8 can be literally anything.
Oh, you're right. You're right actually.
But no, actually it turns out that because on 8 we do a try me else to 13, right? And that's a trust me. The only predicate we have that only has that has exactly two cases is triangle. So that is actually triangle with arity 3.
Oh, wait a moment. I completely forgot about that. This triangle that is being called is actually going to this one.
Yes, it is because it's
That,
setting up
oh,
the
fuck
yeah,
me.
because it's setting up the tail recursive loop. loop.
Yeah, of course this
It's
is
it's
tail call.
filling.
Of course, of course.
Why would it not be? It's literally equivalent to doing a list append.
This would not be
Except we're allowed
Mario's version if it was not tail
except we're
call.
allowed to reverse the list, so it's actually efficient. Well, it's
Uh,
linear on the one on the left, which is kind of efficient, kind of not.
anyway, so actually I take that back. So what we're doing here on these things, we are actually like putting the registers to be able to call triangle with arity 3. So we put new on register 0.
No, that would be the case if you were looking at the trace of the execution, but this is the compiled code, right, in memory.
Yeah, but I'm trying to follow what's going on the compile code. I know that we're not going to be able to reproduce the loops, right? Because this is just like it's going to loop it by itself, and the evaluator will be able to show us that better. I just want to see if the instructions are correct because we need to understand what's going wrong, right? My bet, my money is on unify function.
That's probably correct. Actually, we were in the middle of refactoring that to not be mutable, right?
No, we are not in the middle of that. What I said was, at some point in time, a very great soul would have to have the patience to go into the appendix and rewrite the unify function immutably with the new design, which we have no clue how far we are from it. That's what I said.
All right. All right.
But let's make sure that that's the problem. I don't want to spend. Well, it's not going to be wasteful because that needs to be done. Let's see if there's the only thing that needs to be done. So I have new here, and I'm guessing this is that new.
Yes.
Then we put out. Well, we put. Yeah, this is what I don't understand. What the heck is going on?
I'm basically saying, okay, I'm doing, I'm moving the, I'm doing a get variable from x1, which is the argument, to x4, which is a temporary.
Yeah, but then I am doing the same shit with 2 and 4.
Then I'm
Well,
moving
not
from
the same
x4
shit.
to x2.
Not the same shit actually, because this is get variable, this is get value.
Try me else. And then this should eventually hit a proceed. Yeah, it does. Yeah, this is the base case for a triangle with 3 arguments.
Wait. So where are we preparing to call that? Like where are we preparing to call this? Where is this?
That's later in the compiled code, actually.
That's later.
Yes.
Interesting. Interesting. Okay. So this stuff here, all of
Yeah,
this
from 8.
is
Yeah,
line 7.
from 8. Yeah, from 8 all the way down to 12. That's line 7.
Okay. Then we do trust me, and this is allocating 3. And in here we have some stuff. Well, this is definitely this body because it's crazy. It's doing a bunch of moves. This successor. Yeah, I have a question. Is this successor this one or this one? Do you know?
It's the second one, I think.
I also
Let
think it's
me
the second one.
let me check that actually. So we're doing a get variable moving 0 to x5 and 1 to x4. Okay. Then we're moving the out to y0, which makes sense because we're going to save it for later. Then we do a put structure of the successor on x5, and we unify that with y2. We unify that with y2, which is probably the previous variable, I would guess.
Yeah, I think just looking at it like superficially, I think the code generation is right. I actually want to go to the evaluation now
Okay.
because And here's what pisses me off. We're not getting a problem on unify. We're getting a problem on get structure. Again, the same shit. Again. Okay, so we do a bunch of put structures. We do a set variable. We call triangle with arity true. We allocate 0 because there's none permanent variables in there. Then we do get variable to true 0, get variable 3 1. We are basically moving the arguments to these other registers. And we already occupied x1, so that's why we need to do it like this. Then we do a put value from true to 0. So is this a no op? Could this be removed with this and do nothing?
I think so, yes.
Then we do have a put structure on the new. Then we do put value x4 and 3. Okay, so this is basically preparing. What is this doing again? I keep forgetting, man.
I mean, the line 5 could just be 2 instructions. Well, 3 if you include the call as well. Let's see, we'll do a put structure with the new, and then we do put values to move the temporaries back to argument position.
Mm.
Yeah, that's very unoptimized. It works, but it's suboptimal.
Yeah, no, but we can fix that later. Well, whatever. I don't remember anymore, but I think you said something that makes sense. That is, we are preparing to put stuff on the argument positions. I don't remember why we need to do that. Why can't we just use these registers instead? But whatever. We call triangle with 3, and then go to 13. So I'm guessing we go here. What is 13? No, 13 is the trust me. So this is already this, right?
Well, we are doing the try me else, setting up the line 9 as the else.
Oh, okay. So we're actually doing this then.
Yes.
Then we do the get structure with this new, and then we find an unreachable. So let's actually see. What the heck is that? Okay, that's something new from Tremax. But that's cool. So then we go to here. Uh, yeah, get structure. There we go. So yeah, it's getting here, man. It has something else different than a reference in there. Interesting. Interesting, interesting, interesting. What do you think it is in there?
There is a chance it might actually be a structure.
Hmm. Let's try. So print end line. I don't remember how to do that. Is it show? Yeah.
It is.
Boom.
It's actually a structure.
Is that wrong?
Mm, we're
And
kind of assuming that the registers will always have variables, so in that sense, yes, it is. But in
well,
principle, it should work. Like,
well,
there's no particular reason it shouldn't.
but why did it fail? I can search on the snippets. Are you kidding me? They do have get structure, right? Ah, fuck.
Yes.
Yeah. So we're gonna have to understand what's wrong with ourselves. Well, we're gonna have to find the get structure implementation ourselves. But hey, could we make it with just like everything instead of just references? And what pisses me off the most is that this is a reference with an address. So that seems double wrong. That actually seems double wrong. Unify. What do you think? Here it is. Wait. What? Ah, this is not a book problem. This is our problem. I see.
You know what it could be? It
The
could be the
get
trail actually.
register. The get. I don't think it is. Well, but
Hmm.
don't listen to me. What I think is that this get register is wrong.
This get register is wrong.
Because if you look at the book implementation, it does dref, which we do here, only after getting the register, right?
Well,
And
this
then
get
we actually
register
care about if it's a structure.
well, this get register is basically the X of I on the very first line actually.
Yeah, but I wonder if we could do stuff like this.
That's probably not gonna work.
Oh, but I said nonsense. We know X is a structure. We know that this is not gonna work, help us. We already know that for a fact. Okay, so man, there's something weird going on. What do you think is wrong? And why the previous program worked? Because we're not doing anything outlandishly different than before.
Go back to the terminal, please, real quick. I wanna see something. Okay, so we do the try me else. We do the get structure. That fails.
Because in that register we don't have a reference, we have a structure.
Because in that register we have a structure. X0, put value x2, get variable x2.
Well, I wonder if it's this, because this is putting a structure in x0. And you're trying to get a structure on x0.
We're doing a put structure on x0.
Yeah, but this doesn't make any sense, right? Because this
Go
is
to
way below before.
no. Go to the implementation of put structure real quick. I want to check something as well over there.
Put. There we go.
All right, put structure. We create the structure cell. We make the functor.
We are doing stuff on the heap. Should we do that?
We put those in memory. Yes, we should.
Are you sure?
Yes, because you
Yes,
can't fit
yes,
a
we're sure.
structure in the you can't fix a structure in a register in general.
Yeah, yeah, yeah. It's very odd that we decided to. Yeah, that's really odd. Let's not do that.
Oh, I think I see the problem. It's the final, it's line 49.
What's the problem?
Line 49, we're putting the structure in a register. We should actually put a reference to the structure in the register.
A reference to the structure. Do you mean um, reference uh, h plus 1?
Um, it could just be a reference to age register as well.
But the structure is not in h register, it's in h register plus 1, no? Oh no, you're right. I'm actually putting the structure on h register. You're completely right. Like this. Alright, there we go. Which is kind of funny because now it's very close to set variable. Interesting.
Well, it should be. They do very similar things. They both allocate. It's just that set variable allocates a new variable and puts it in a register and also puts it in memory. While put structure allocates a structure.
160. Okay. Okay, I won the bet. Give me all the money, Italian for everyone.
No, 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 no.
Oh,
Go back real quick.
yeah, man. Unify is wrong.
Hmm. Okay.
Okay, now we went way further, actually. Way further. Let's actually see where we stopped this time. So,
We actually call the plus.
yeah. Well, we called triangle 3, right? So this happened. Then we did this, immediately did trust me to go to the second one. Then we did all of those things, blah, 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 call plus. So we reached this. And then there's a try me else, of course, because there's two definitions in here. The
You
first one
know, actually,
immediately said no,
you know,
retry.
Lemos, let's slightly optimize this program. Swap the order of the triangle 3 definitions.
Do you mean like this?
Yes.
Sure. There we go. Okay, but going back. So triangle 3, we call that. We immediately go to the one that matters because we know we're not going to go to the base case right now. Um, we do a bunch of stuff, then we call plus. The first plus is base case, so we immediately retry. So we go to the second. It should also like do something else, but it doesn't. It doesn't reach the trust me for it to reach this other plus, which is interesting. So I wonder if get variable is a alias to unify.
No, actually, it shouldn't reach the other case to begin with, because we're
Okay,
adding, because we're doing an addition to 0 at this point.
I don't follow.
We're doing an addition to 0, Lemos.
No, no, no. That I follow. But I mean, why shouldn't we not go to this?
Because the second case is actually going to match.
Really?
Yes.
But I think I'm lost then because my understanding is that we are unwrapping the successors at this moment with this.
Yes, but the initial accumulator was set up on line 5 and it's 0.
Wait, it's 0.
Well, yes,
So,
the initial accumulator is 0.
mm, wait, so this is new, right?
At the very beginning, yes, it is.
So it's gonna match this because this is whatever, and this is whatever, and this is whatever, and this is whatever. So it's supposed to match this thing, right?
Yes.
Okay, that's actually kind of weird because my mind was okay. We're gonna unwrap this stuff and count as we go. But we're kind of doing the opposite. We're kind of creating this from scratch until we match this thing, right?
Actually, your initial interpretation is correct. It's just we're summing the numbers backwards.
What does that even mean?
What?
We're not summing, we're not doing 0 plus 1 plus 2 and so on. We're actually doing 4 plus 3 plus 2 plus 1.
Exactly, but
Well,
we just reached base case.
well, that's because the initial accumulator is 0. So in fact, we're doing 0 plus 4 plus 3 plus 2 plus 1 plus 0.
Ah, okay, that helped. Thank you, Marie.
You're welcome.
Okay, you said. Wait a moment. So this is just unification. This is unification of this with this,
Yes, it should be.
and it fails on line 160 because the pattern matching is unexhaustive. Because get value is just an alias to unify. Unify is a sin on Earth. And it's breaking because this is not a reference. Okay, let's actually see how far we are from the final version.
Very.
Well, it's a very long function to be honest. And here it is. Uh, okay. So let's actually read. So the arguments are the same. We receive two addresses and the computer, and we need the computer because we're gonna use a bunch of the memory. So we do a push on A1, uh, and we are putting addresses in there. I don't remember anymore when to use references and addresses in this context. So whatever. Uh, then you put the fail to false. We put the fail to false. Wait a moment. Marinho, aren't we using the fail for backtracking? Or am I going crazy? I'm very
Maybe
sure we're
both are
using...
true.
Yeah, but that sounds wrong. Back...
In the computer, we are, yes.
Man, I think that's kind of wrong, no? Because we are using the same boolean for two different things. Well, I guess it's not a problem if this is not a recursive function, but that's kind of sus. Okay, we set those two things. That's cool. Then we're gonna start the while loop. Uh, okay, this is that while loop. So while the PDL is not empty, and or you haven't, well, in fail, while that's not true, we do some stuff. So the first thing we do is to do a, well, he's doing a pop, but we do a top, probably because we're not going to remove the element from it for whatever reason. And we are establishing on the line of the arrow that whatever you're popping should be a reference. Is that true? That's hard to say. Anyway, what do you think?
Actually, that's not gonna work because we're putting addresses on the PDL, right?
Well, wait. Are we supposed to get those addresses in here as the first
No, no,
step?
no, no. Scroll up. You were showing that we were putting addresses on the PDL earlier, right?
Yeah, it's this.
Yeah, that means we should replace those references with addresses, actually.
So address, like so. And no, they are not addresses as well.
They are not addresses as well.
Yeah, they are. Well, I don't know what they are, but it's saying that the pattern matching is failing. So whatever they are not references and they are not addresses. Can they be
Can we
something else? That's actually a good
can we
question.
print can we print those?
Fuck. Uh, they can be literals in this version. Oh my
That's fine. We don't have literals.
god. Yeah. Well, in that case, it can only be a structure, no?
It can be a reference.
No, it isn't. It was a reference here written before. Look. And it failed on the same point. So they are not references, they are not addresses, they must be structures.
They can be counts. They can be empties actually, if we mess something else up.
Yeah, that's really wrong if they are empties. But I
Just
wonder
print
why the heck did we do that? Why did I do that?
just print the generic P1s.
So print cell show generic. They are empty. Awesome. Wait, if they are empty, brother, if they are empty, that means that something
We're reading
before calling unify is wrong.
we're
Yeah?
reading an initialized memory. Yeah.
But how to discover that? Uh, always great stuff. Always great stuff. Let me just check if you're not doing anything else differently. Because essentially, the reason that I did that, I 100% know why I did this, is because I need the numbers inside in order to use them as to index the memory later. That's why I did that. As you can see in here. Uh, yeah, this is really different, this version of Unify with this one. Because this one, they actually grab the stuff and bind it. We don't do that at all. So that's something. Ah, okay, there was another reason that I wanted to do this, is because I want to call deref, and I'm passing them as addresses. Should I do that? What is the version here of deref? This one. Let's actually check how deref is done before I continue. So we actually do a get on the store, grabbing the using a as the address, and then check if the cell is a reference, and the value that is inside that it's not equal to a. If that's the case, then we keep the the recursion. Otherwise, we just return a. Yeah, this is the version that we implemented as well. Yeah, that stuff. Okay, so where are we doing the messing of the memory? Hmm. Where are we messing up the memory, Marinho? Where are we messing up the memory? Yeah, that doesn't make sense. This pop here, this needs to have something in order to the ref to type check. So this cannot be empty in the PDL. Hmm. Marinho, are you there?
Yes. Mm,
Uh, this push is alright, right? Oh, this is using a very
hmm.
dirty trick. There is a mutable reference in here.
It's
Why
not
do we have
split.
that?
Probably because um, we wanted to keep the mutability contained, and we
Oh, we
didn't
don't
want
need
to
that PDL. We actually don't need that anymore.
because. Oh, well, why exactly? Actually, because the
Because
PDL is
we
a
don't
stack.
actually have the we don't have the trail growing backwards anymore.
No, but no, that's fair. We can change this later. But the reason that we did this way is because then the module controls the stack behaviors of popping and pushing, and we don't have to care about it from a usability perspective from the callers of this. But I don't think that's the
Well,
issue. I don't think this is the issue at all.
the PDL tracker is less than the PDL start.
Yeah, this was done at the times that they were combined because this message doesn't make sense anymore now that we separated them. So if you have something wrong, we update the tracker and we put something in the position that it was before.
Ah,
That's it. That's actually it. Hmm. Interesting.
ah. Wait, the PDL grows backwards apparently.
Well, that was when we had the trail and the PDL kind of fucked up together.
Ah, can we get rid of that mutable variable since we don't need it anymore, apparently?
Sure. Boom. And
Those should just
now,
be limited puts and gets, I guess. Well, actually, no, this is a push and a
okay,
pop,
so
right?
yeah, the reason that we need it is because you don't send the index. You don't have control of because it's a stack. It should do that by itself.
But we have stack get and stack put taking an index.
Well, it's because whatever the memory region we call stack, we don't actually use it as a stack in the
We
book.
do actually.
We don't.
We do.
No, we don't. The book uses a stack in indexing it as an array.
But it treats the frame, the stack frame as an array. But
Yes,
it is a stack.
yes, yes. But to keep it closer to the book, yeah, I didn't do the pushes and pops on it. So that's why it works like that. Anyway, what is wrong? Guesses. Mm,
Everything.
great. That's actually great. 161. Yeah, this is trying to unify the plus. Well, the second rule of the plus because there's a retry me else and get value calls unify. And here's the thing. We have the numbers, right? So these are the numbers of the no. Well, these are the register numbers. We actually need addresses, right? We actually need addresses. But are we using these? Where are we getting the addresses from? Do you know, Marinho?
Um, Go to the place that calls unify, and that's where the answer is.
No, 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 no. This is unify is being called because it's get value is an alias to unify. So if I go to get value, it's gonna call unify, and get
Yes.
value uses if you have two references in there. Ah, okay. We actually do two get registers using the X register and A register arguments from get value, which are those. We do we get them ourselves. They need to be both references, and if that's all that holds, we do call get value with those values. I wonder if they are swapped. That would be kind of funny. I don't know if that matters as well. Probably
Mm,
doesn't. Yeah, it
it
doesn't.
doesn't.
Yeah, it doesn't matter. So, um, what are we putting those registers? When are we doing that? I think that's the kind of the question. I think it's true, right? Because we do a get variable with 3. Agree?
Yeah.
So I think we're putting stuff on 3. I think. What the heck is going on with true?
That's because those are supposed to be the same variable, actually.
The same variable. You mean the same variable across the things you're trying to unify?
Yeah, this is a plus, right? We're checking the base cases.
So in this case, uh, yeah, the way I'm trying to unify this with this, right?
Yes.
Because retry me else, so second, and this is what we were doing before because we called triangle with arity 3, and we already did a try me else on it. So this is definitely going to this. So my question is, which variable is set x true?
It's the out on the right.
So you're saying that it's this with this.
Yes.
Wait a moment. This hasn't been allocated yet, right? Because this didn't appear before. Or am I wrong?
This needed to be allocated in the triangle body.
This needed to be allocated in the triangle body. Mm, mm, yeah, I don't know where that is happening in here, actually. But it's probably something
Hmm.
here.
We're doing a get variable from x2 to y0, and then we're doing a put variable from y1 to x2.
Oh, wait. Y1 is permanent, right? And new accumulator is definitely permanent, right?
It is definitely permanent, yes.
Hmm. Wait a moment. So that's actually tough. How many permanent things we have in here? Three, right?
Previous is permanent, new accumulator is permanent, out is permanent, yes.
So three. So we should have y0, y1, and y2. Agree?
Yes.
Where is y1? Here.
Maybe that's not being properly initialized for some reason.
I have another question. Uh,
Okay.
what are we moving in here?
From right to left.
Right to left. So, oh, so these are the arguments for triangle.
Yes.
Okay, so these three things we are putting on those three other things. So let me check. Previous, success of previous is on 0 and continue to be temporary. That's wrong, right? This line is wrong. Or am I mistaken?
We're doing a put structure on x5.
Ah, wait. It's doing that on successor, and successor is temporary. That's why it's on X. Am I correct on saying that?
Yes, and then we do a unify variable with y2
Yeah, that's probably doing the
after we do.
previous.
Yeah, that's binding the previous.
Yeah. So this thing is doing the ACC because ACC is temporary, in fact. Then this it's moving out, but out needs to be permanent at this moment because it appears here. So it goes to I0. Then we
Yes.
put the functor structure in memory as well, and we say that the register that has its stuff, it's x5, which is correct. Then we unify y2, unify variable y2 because we need to save previous.
Yes, we're basically unifying this with the payload of the successor
Put
functor.
value does the same shit as get variable, but left to right, right?
Yeah,
Okay, so
kinda.
this is grabbing the successor with previous and preparing it to call plus, right? And this
Yes.
is grabbing x4, which is ACC, and preparing, yeah, putting on the second position to call plus. Great. Then we do put variable, which again I forgot what that does.
Oh, you know what's kind of neat? We kind
What?
of accidentally have common sub-expression elimination here going on.
Yeah, that's great. I don't remember the difference between put variable and put value anymore. But this is doing what seems correct to me, which is pick permanent
Uh,
out.
put variable is actually used when you are creating a new variable, as opposed to put value, which you assumes the variable already exists.
Oh, so this is introducing new ACC
Yes,
and already putting it in the third position to call plus. And then we call
yes,
plus.
and then we call plus.
Then we try to do stuff. We fail because this won't unify.
Maybe the problem is in put variable.
Let's check that. Put variable.
Okay, what are we doing?
Oh, okay. What is the implementation? Yeah, put variable. So what we're supposed to be doing is we create a reference with the H register. We put that into in the heap using H register as the index. Then we
Yeah, that's exactly what we're doing.
yeah, but then we do set register on A passing the reference with H. That's correct. And then we pass X register. We put in X register. That's a little bit suspicious. Does the order matter?
No, it doesn't.
No, it doesn't. You're right. You're definitely right. It's so hilarious that this. Oh man, this is just an idiot to this. Uh,
It's
yeah, I don't see any problems. Do you see any problems?
not really, no.
Are we doing set register correctly? Because these functions we kind of made them ourselves.
I mean, semantically, this should be overriding the register with whatever value we give it as a right?
Yeah, but in this case, for example, we are going with the Y register, right? We're doing a put variable calling the Y register with a Y register.
Yeah.
Is that correct? What we're doing there? Because I don't remember anymore. Why do we need the +2 and the +3? I'm already lost on those.
Because the e-register points to the very base of the stack frame, which contains, if I'm not mistaken, it contains the address of the previous base of the stack frame, or the base of the previous frame, I should say. So we need to skip over that, and then +1 is +1. I don't remember what's in e-register +1 actually.
Um, stack. There it is.
Oh, okay, +1 is the return address. That makes sense. Then +2 is the size of the stack frame in terms of how many permanent variables it has.
Mhm.
And then everything after that is a permanent variable.
Hmm. Okay, I think we're kind of stuck on this. Uh, we we can finish for today. It's already time.
All right.
I'm gonna finish the recording now.